Hey there, I am not a clone of Planet Peterson that was left too long in the incubator. My name is Grayson Hawk, I have a different YouTube channel, and this is my first time on the Planet Peterson. Actually, it's my first time on any planet other than the Earth. I'm very curious about what kinds of things that they have here on this planet.
Mr. Farina!
Huh? What's that?
Here!
What do you want me?
Go! You don't do it! You just talk!
Oh no. Oh, they have those here too? Oh, I thought we had enough of those on Earth.
You don't have enzymes because you couldn't make them here. You couldn't make them there. No enzymes. You're lost.
James, didn't we already go through this when I debunked you on my channel more than a year ago at this point?
We already established you don't have enzymes. There's no enzymes yet on the
Shouting is
prebiotic
totally an
Earth. You couldn't
argument.
make them. You're clueless on that. No enzymes. You're lost.
Okay, you still are clearly not getting it. So let's just do this, shall we? And debunk James' tour on his abiogenesis arguments once and for all on Planet Peterson. Let's get started. The reason why I've decided to select this particular debate out of James Tour's mounds of content about abiogenesis is because he had to shorten his criticisms into only just these 5 points here that he moves through during the debate with Professor Dave. The reasons that he thinks that abiogenesis is just so flawed that he says that we are, quote, utterly clueless about the origins of life.
If my opponent is unable to supply all 5 criteria for life, then we're currently clueless on the origin of life. But since I don't think he'll be able to supply even one of the 5, it will show that we're not merely clueless, but utterly clueless.
So let's just break down these 5 points, shall we?
Polypeptides. One of the things that we have to make in order to have life are polypeptides, where we take amino acids and these amino acids have to couple. And when they couple, it will form a dipeptide.
We get it, James. You have memorized the chemical structures. Gold star for you. You could have just done a PowerPoint and saved everyone the time. He thinks that if his debate opponent cannot write the chemical structures on the board and complete the chemical reaction as he stipulates it, then that means that we're clueless on abiogenesis.
What do you want me?
Go! You don't do it!
But no, all it does is get you brownie points with teacher James that you have all these chemical structures memorized. It's really not pertinent at all to any of these arguments. Let's just get to the argument, shall we?
This dipeptide is one of thousands and thousands and thousands that would have to form. If you were going to make a polypeptide, you'd need at least 100 of these for a very small polypeptide. Mr. Farina, show me the prebiotic chemistry that would do this coupling. Be my guest.
Okay, James, here is the prebiotic chemistry that would do such a coupling to form a peptide bond between 2 amino acids in an aqueous solution. We've known about it for over 20 years now. It's catalyzed by a molecule called carbonyl sulfide. Here's the study that showed it. So this is the chemistry, I guess, that James Tour was just expecting Dave Farina to have memorized so that he could just write it on the board for some reason. Like, it doesn't matter whether or not Dave could draw these structures on the board with chalk because he showed this study in his presentation. So he cited this source. James should have been familiar with this source already. Oh, and also my name is Grayson, not Mr. Farina, for future reference.
Thank you. So this way I could address Grayson without taking on his channel, because I'm not here to support his channel.
Well, hopefully that means that you'll respond to this video, because it's not on my channel this time. Thanks again, Planet Peterson. Your move, James.
Half of the amino acids have active side chains, and these guys play this game of not including these ones that have carboxylic acids, not including the ones that have amines.
So Dr. Tour responds back at this point saying that he specifically wants to see the peptide bond formation between two amino acids that have highly reactive side chains. Now, in his initial video on this, James claimed that you can't form any peptide bonds in water.
Hooking together of two amino acids to form a dipeptide, two amino acids stuck together, and this is what's called a condensation reaction. You don't do condensation reactions in water because you're generating water. So the water, so if you're in water, it's going to shift the equilibrium back to the starting material. I don't understand why some would suggest that you do condensation reactions in an ocean like this, in water. How can that be?
Notice how it isn't lysine in his original video, just a generic amino acid.
Tell me about that. How do you do condensation reactions in water? Have you any references on these?
And then after seeing the papers, like that carbonyl sulfide paper, clearly showing that we've been able to do this for over 20 years, now he's moved the goalpost, and now he specifically wants to see it done with lysine, because he knows that the carbonyl sulfide method is not going to work for amino acids that have such highly reactive side chains like lysine. So at this point, I think it's maybe worth it to take a quick step back and just briefly gloss over these terms. So amino acids are basically the Lego building blocks of proteins. Each one has a little backbone that has a positive end and a negative end, like a magnet. So you can link them all together and build up a protein, and each one of the 20 different amino acids has its own unique side chain. So on top of the little Lego building block, there's a side chain. Some of them are very simple, just little rods, some of them have little branches, some of them have rings and unique shapes, like a very long branch with a little positive charge at the end. And that is lysine. So it's like this really long branch that can swivel and flex and rotate with a little positive end at it. And so this allows it to do its functions in the cell.
You can't do this coupling.
Acylated aminonitrile plus unprotected amino acid hydrolyzes the pH 7 to form a dipeptide.
Which amino acid? Hydroxylated ones, never carboxylated, never deaminated.
All proteinogenic side chains. All
from aminonitriles.
James, I'm telling you, he did this with lysine. Okay, so the side chain thing is not a problem.
Dave counters with a paper showing exactly what James says cannot be shown. A paper with the peptide bond being formed with an amino acid where one of them is lysine, right? And it requires an intermediary where a chemical comes in, binds, and basically caps it and protects it while the reaction goes forward, and then undoes it at the end. And this is all using prebiotically relevant molecules. Let's see what James Tour says in response, shall we?
Look, he got coupling with lysine, regioselective lysine ligation, the most selective peptide ligation that tolerates all proteinogenic side chains.
But
he did this
does not
with
do
all side
an
chains.
amino acid coupling. He's got.
What are you talking about? Prebiotic catalytic peptide ligation.
There's no amino acids there.
Yes, it's amino acids.
Okay,
what are you
go
talking
to the
about?
equation of that. Go to the equation of
I don't
that.
have that one, but you're just lying.
So James just lies about the study in question, which clearly shows the synthesis of peptide bonds using lysine and simple prebiotic reactants, something he said has never been done. This study shows just that, and he dismisses it by saying there are no amino acids, as if amino acid derivatives somehow don't count, even when they're completely prebiotically relevant. Like, just because it's not the exact reaction that you drew on the board, it doesn't really matter. The end products of the reaction are the same. The reactants are simple and prebiotic. That's what matters. James is simply obfuscating the fact that this study proves him wrong. You can achieve prebiotic peptide bond formation for all 20 amino acids in water, even the bonds with lysine and other amino acids with highly reactive side chains. Whether starting with amino acids or peptidyl nitriles, like in this study, it doesn't really make a difference for the final results. So James's first point about polypeptides already proves by his own criteria that he's just wrong. So already, less than 10 minutes in, James Tour has been debunked. But it gets worse for him. You see, in the presence of prebiotic catalysts like volcanic gases, amino acids will spontaneously form what are called amyloids, shown by Greenwald et al. From 2016. Amyloids are a type of protein that forms when the positive and negative ends of the amino acid Lego blocks form an interlocked sheet, like a sheet of paper, and their side chains are extending on both sides of this kind of wrinkled up looking sheet. And these amyloids will spontaneously form from just simple amino acids prebiotically near the volcanic gases at hydrothermal vents, for instance. And they can catalyze other reactions just like enzymes do. And enzymes are basically just proteins that have jobs. They have functions, right? So even before RNA and DNA, before ribosomes and cell membranes, you can already have catalytic amyloids acting like enzymes on the prebiotic Earth.
You don't have any enzymes. No enzymes.
Oh, we got enzymes, James. Welcome to the amyloid world hypothesis for the origin of life. If only I could have been there at this debate all those years ago. I could have brought up some of the unfounded assumptions that James Tour has made about polypeptide bond formation and how, if it doesn't start from amino acids, then it can't start from anything else, and all 20 amino acids have to be there from the very start for life to begin, and all these tacit assumptions that James is just making. I wish I could just be there to point those out in person, and so that he could get a chance to maybe defend his argument and defend his position and try to justify those assumptions. If only, right?
Next question.
Dr. Tour, it seems like most of your critiques rest on so far unjustified assumptions, so I would like to give you the opportunity here to justify at least one of those assumptions. The very first one, your very first question to Dave, seems like you admit that you can form peptide bonds for some of the amino acids in aqueous solutions without protecting groups. You point out specifically lysine and arginine, and I would like to ask, why are you assuming that lysine and arginine and all 20 amino acids were there from the very first, the origin of life? Could you just justify that assumption for us? Why couldn't you have life from like just some of the amino acids that later on?
30 seconds.
Okay.
So my contest on the amino acid claims was he kept saying amino acids are simple to make in water. That's what he said in his series. But then, when challenged on that, he came out later and he said, when activated. When you activate them, they go from being zwitterionic to being non-zwitterionic. This is what I was getting at. So somebody coached him on this. Tour must be right on activation. Now, to your next question. Could there have been life with half of the amino acids? We have no idea. Even if I gave you half of the amino acids, now what? Let me tell you, because if you have 100 amino acids, the chances of getting anything with prescribed information is say you have half of them, is 10 to the 100th. Yes, it is. Now, the chances of that folding, a 100 mer, the chances of it folding are what? 10 to the 90.
It's been shown Greenwald et al.
All right.
Okay.
So Leventhal paradox. One forms. But Leventhal paradox. No way. The vast majority do not fold.
Time is up
They
for
don't
that
fold.
question.
So, as you can see, James Tour just straight up did not even attempt to justify the assumption that I pointed out, which is an assumption that his entire argument chain rests upon, right? If you don't need all 20 amino acids right from the very start, and life can form with only a smaller amount of amino acids, then it doesn't matter whether or not you have lysine polypeptide bond formation. Like, the entire center point of his whole argument so far is resting upon this assumption that it is necessary for the origin of life. That's an assumption that he's made. I gave him the opportunity to justify that, give some kind of reason or evidence why we should think that. And what does he say? He said that we just don't know if life could have begun with less than 20 amino acids. So it's like, my dude, if you admit that, which is my point, then why do you assume that we need lysine specifically?
We have no idea. Even if I gave you half of the amino acids, now what?
The entire argument that he's crafted over the years about abiogenesis is that, oh, well, we need specifically to form a polypeptide bond with lysine and these highly reactive side chains in order for life to begin. But he's just admitted, when I asked him to please justify that claim, he's just admitted that we have no idea. We don't know. So then, James, don't assume it for your argument if you cannot justify it. And it gets worse. Weeks later, he went on an apologetics podcast and had this to say about amyloids, which for some reason he associates with me instead of the actual researchers in the field doing the actual experiments on amyloids.
Last question from Tony Maurice, and he says, Dr. Tour, are amyloids solving any origin of life problem? And
the answer is the answer is no. This is from Grayson. He's a young man who spoke to me at the debate, and then he made a video about me. He's a YouTuber. It became very clear to me he was just trying to promote his YouTube channel by provoking me so that I'd contest with his YouTube channel like I did with Dave's YouTube channel. You know, Dave Farina's YouTube channel, when he first provoked me, had 780,000 or so, 700 and something thousand subscribers. Now he's got 2.5 million. So you poke Jim Tour, he goes after you in your YouTube channel. So Grayson did the same thing. He came up to me very nicely at the end of the debate. He talked with me, and then he made a YouTube video which was not flattering at all. I mean, and just took little segments out of context. And so that's Grayson. And so I said, I'm not going to go on your YouTube channel to try to bring more people to it. No, what he does is he says, okay, in amyloids, they don't need to fold. They can fold. They can get into their position naturally.
The last thing that James said was about folding. And this was actually concerning to me because I assumed that James had to have taken some sort of biochemistry course where he learned about protein folding, but apparently not if he can say something like amyloids don't fold. Definitionally, amyloids are folds. What makes something an amyloid is that it has a specific type of fold, the beta-pleated sheet structure we talked about earlier, an amyloid fold. Maybe he's thinking about the way that amyloids grow, where they just add on amino acids onto the same template so that they can replicate their exact sequence and pass on pseudo-genetic information without genetics or DNA. That's one of the things that makes amyloids such an amazing candidate for the origin of life. Maybe he's thinking that that means that they are growing and replicating without protein folding, but they're just folding spontaneously. They just don't need chaperone proteins to help them fold into the right shape, James. Like, they still have secondary structure, they're still amyloids, so this point is just like really concerning from somebody who's supposedly an expert in chemistry and chemistry that's relevant for the origin of life. This is like an introductory biochemistry level error that he's committing.
And then he says, and you don't have to worry about it folding because amyloid doesn't have to fold. Well, the vast majority of enzymes need to be folded. Amyloid is a specific type. And nobody in their right mind looks at this and says, this solves the polymerization problem. It doesn't, because the free energy is positive. And so those don't want to polymerize. They keep going back to starting material. Ahmed, you know something about free energy being an engineer. So when the free energy is positive, it keeps wanting to go back. They hydrolyze, they go to starting material. So this idea that amyloid solves it, this is another naive idea by somebody who understands very little about the science and the chemistry behind this. You never solve the free energy problem in making those polymers. They always want to go back. And even when you try to make them with 10 amino acids, nobody's ever shown functionality from these things. And the amyloids aren't just based on 10. So it's a very naive idea.
Yeah, James has absolutely no idea about the energetics of amyloids. They are one of the most stable, low energy conformations that proteins can even take up. It's so stable that the kinematics and energetics immensely favor amyloid formation. That's kind of the whole problem with the buildup of amyloid plaques and prion diseases and everything. I mean, this is just betrays such a fundamental misunderstanding of amyloid chemistry that it makes me doubt that James has ever looked into this. And the fact that he could so confidently and authoritatively claim something so basically fundamentally incorrect about the science should cause anyone who's listened to him before to rethink anything that they've learned from James Tour and to second guess the things that he's saying, like he is some sort of origins of life expert when he clearly is not. He's a skilled synthetic chemist, but here he is getting very basics of biochemistry and protein chemistry just completely wrong in something that an undergraduate student should be able to correct him on.
This is another naive idea by somebody who understands very little about the science and the chemistry behind this.
It's just sad that this man is passing himself off as an expert in front of his lay audience. Oh, and by the way, when I was there at the debate, everyone sitting around me was a member of James Tour's church. Like, he literally stacked the audience with people that didn't know anything about abiogenesis. They didn't know anything about any of this. Some people around me didn't even know who Professor Dave was. They didn't know anything about the topic. They just said, oh, we're from James's church and he invited us all to come here and we're very proud of him. Like, I mean, come on.
And Maurice, you are a tremendous guy. You've been a big supporter of mine, and I appreciate the question. Thank you. So this way I could address Grayson without taking on his channel, because I'm not here to support his channel.
But let's back up to the very first thing that he said about zwitterions, right?
When you activate them, they go from being zwitterionic to being non-zwitterionic. This is what I was getting at.
For those of you that don't know, a zwitterion is just like a very specific type of molecule that has like a positive and a negative charge that are localized somewhere on the molecule, but overall they sum up to where the molecule is electrically neutral and has a net zero charge. That's all he's talking about. So he's like, somehow he thinks it's a problem that if you have some sort of prebiotic chemistry experiment and you manipulate the amino acids somehow, like was in that paper that we showed where they were peptidyl nitriles instead of amino acids, that could accomplish this same chemistry and get the same final results. James is saying that's somehow a problem, that's somehow not prebiotically relevant because, oh no, they're no longer zwitterions, now there's like, come on. It doesn't matter, James. As long as it's prebiotically relevant chemistry that gets you the end products, it doesn't matter if you're starting from amino acids or something else, or a zwitterion or not zwitterion. I mean, this is a complete non sequitur. Now, the main thing that James said in this response here, which, by the way, had nothing to do with my question at all, but is emblematic of one of the key mistakes in James's reasoning throughout his entire career stepping into origin of life research. And that is that he tries to make the claim that, you know, in order for you to have a basic working enzyme, a basic protein capable of doing any kind of functionality, it needs to be, you know, dozens, if not over 100 amino acids long, and it needs a very specific sequence in order to do that function. And he tries to calculate this huge, mind-blowingly huge number of like, oh, well, your odds are 1 in 16 octillion.
This is the enzyme that does this. It is 98 kilodaltons. It's 20 to the 842. That's 10 to the 1094 possible scenarios. If you have anything more,
is that the enzyme that does this
10
today,
to the
or is that the
50th,
enzyme
you don't
that
have
did this
enough
4
time
billion years
in our
ago?
universe. In 14 billion years.
Wow, big numbers, guys.
Yeah, big numbers. So this is the type of enzyme that you would have to have.
Maybe if you had never taken a biochemistry course or you didn't know anything about like proteomics or genetics, then maybe you could fall victim to this kind of reasoning, but James should absolutely know better. Like, he's a very good synthetic chemist, so I know that he knows chemistry well. And In synthetic chemistry, you often are very detailed and disciplined about each step in your reaction, documenting it, getting pure yields. I mean, that's the pride of a synthetic chemist. But that is not the way that biochemistry happens. You've got so many reactions going on, all in the same solution. It's just this complex, chaotic system. It is a synthetic chemist's worst nightmare. But in biochemistry, there's multiple different genetic sequences and sequences of amino acids for a protein that can do the same job. There's degeneracy. And this is a key central point that James Tour is constantly missing, right? He thinks that, oh, well, because the enzyme that does this function today is very complex and has hundreds of amino acids, that means that there's no other sequence that could do such a function. That's the fundamental error in his reasoning, because in actual biology, multiple different sequences can accomplish the same function to various degrees of efficiency, and that's key. That's literally how evolution works, right? Variation in fitness in a population, and then selection acts upon that population. You don't have these high perfect yields. You need to have variation in fitness effects in biology, and this includes right down to abiogenesis, down to the molecular level. In this case, for these early molecules, what we mean by fitness is mostly stability. Which molecules, which self-replicators are the most stable and are able to fastest and most efficiently pass on and replicate to the next generation. And if you have heritability, which we already went over, amyloids do have to some degree. They can replicate their actual sequence of amino acids as one sheet acts as a template where the next sheet is built on top of, and it replicates the sequence of that amyloid sheet. It's incredibly cool. When you have all those factors of variance in fitness effects in the population of self-replicators, and they can inherit sequence information from one generation to the next, those are all the necessary criteria for Darwinian evolution to take place.
He argues that you don't need you can just use a subset. You can just use 10 of the amino acids. You don't need the other 10 amino acids that have functional side chains. Nobody has ever shown that you can get away with just 10 of the amino acids. Plus, even if you have those 10, you have to have those polymerizing. The chances of getting them are very, very hard. So you have 10 amino acids, even if you had something that was 50 units long. So then you'd have 10 to the 50th possible combinations to give you it.
My point is that we don't know how many amino acids there were at the origin of life, whether it was 5, 10, 20, or 200. Different functions have different amounts of robustness in sequence space for what kinds of sequences are able to accomplish those functions. Some functions might be simple enough that literally thousands and thousands, if not millions of different sequences could accomplish said catalyzing of a reaction or whatever the function is to some degree or another. Some are going to be really good, some are going to be really bad. But there's a huge number of different sequences that could accomplish such a task. And James doesn't account for this at all in his calculations. And I would challenge James to find even one enzyme in the body that can only accomplish its function with just that one sequence. Every single enzyme has multiple different sequences. And James then has the audacity to make the completely false claim that nobody had ever spontaneously formed proteins from amino acids that had catalytic function and could function like an enzyme. Greenwald in 2016 showed that you can spontaneously form amyloids prebiotically from volcanic gases. They form hundreds of amino acids long, and they have catalytic functions and can behave like enzymes and catalyze reactions. Exactly what James just said had never been demonstrated. I cited it to him to his face, and still to this day, he'll probably continue making the same claim and pretending like no paper has ever shown it.
The chances of that folding, a 100-mer, the chances of it folding are what? 10 to the 90. All right.
Okay.
So Leventhal paradox.
And that last thing that he mentioned about the Leventhal paradox is a complete non sequitur, because we have literally watched amyloids spontaneously forming and folding into their beta pleat formation in aqueous solution in the lab without any chaperone proteins. There's no paradox involved. We've watched it happen. So this is just an excuse bringing up some thought experiment from the 1960s before we understood the biochemistry of chaperone proteins and how actual protein folding works. Isn't gonna help you, James. So what is that, number 2 or 4 now that James has been debunked so far? But after this debate, I actually went up and talked to James Tour about this, and I brought up this point about amyloids, and he told me to my face that he was not familiar with amyloids and that he would need to do more reading about them. Okay, so somebody that claims to be an authority in origin of life research has never heard of the amyloid world hypothesis. Okay, all right, fine. It's kind of a red flag, but I then emailed him all these papers on amyloids so I know that he has them, and then silence. He has not gotten back to me. I challenged him to a debate. I said, James, let's debate this. Let's talk about these papers. He accused me of being a clout chaser and said that my channel was too small for him to engage with. So that's who we're dealing with here with James Tour. Alright, so let's just get back to James's arguments, right? We were only on the first point. So let's just speed through the rest of these points, shall we? Because they all kind of rest upon this first point being true, and as we already saw, it's not. So the rest of the points don't actually follow and are pretty easy to just knock down one after the other. Let's cut back to James and see how he's been handling all this, huh?
This is down.
I'm sorry, man. I just had to. What was the argument you wanted to make, James?
In order to do this biologically, not prebiotically, but biologically, you have to use an enzyme that has about 1,000 amino acids in it. So the probability of that forming randomly would be 20 to the 1,000th. I mean, it's just a crazy big number. If something's bigger than 10 to the 50th, you don't have enough time in the universe. Here, you wouldn't have enough time in a billion universes.
Oh, right. I see. It's the same old. Well, we do have the enzymes prebiotically. We've got peptides forming spontaneously that have enzymatic activity. So, sorry, James. Well, we got them. Next.
You don't have any enzymes because you couldn't make them here. You couldn't make them there. No enzymes. You're lost.
Dude is really worked up over enzymes. So basically, James spends the rest of this debate misrepresenting and misunderstanding papers that demonstrate that the things that he's saying are not true. Like, he tries to say that you need to have perfect yields of RNA in the exact right conformation, or else...
What you have to be able to do is show me chemistry. I'm asking you specifically for chemistry, not a bunch of nonsense here. Show me the chemistry
Not a bunch
to
of
get
peer-reviewed research.
this reaction to go such that you get coupling between the 3' hydroxyl to this 5' site. So you need 3', 5' coupling to the exclusion of 2', 5' coupling.
Dave just shows a paper that shows the opposite, that there's actually selective pressure for the right conformation of RNA, and you can have a population of different RNAs and different conformations. He demonstrated that with the paper, and James Tour just says nuh-uh.
Without an
James,
enzyme, it is never
You
been
are completely clueless.
It's
This has
over.
What's the first word in that paper? Functional. So we're talking about RNAs that still have catalytic behavior, despite having a mixture of 2,5 and 3'.
His amount of 2,5 to 3,5 is not 30 to 70%. If you have a 0.1%, you're okay because you'll have runs, but not 30 to 70%. Show me the amount. Your guy Deemer never tells us how much is there.
James, look, the
And
research
Benner
shows
never told us how much is there.
functional RNAs. So it doesn't matter how much 2', doesn't matter how much 2'.
It certainly
He's
does.
allowing them to
And what
polymerize.
about branching?
My God.
It's not there. It's not
Let's
there.
see.
Nobody has ever done this prebiotically. You're going to be looking through your papers a long time. It's never been done. Without an
James,
enzyme, it has never
You are
been done.
completely clueless.
It's
this
over.
has been done.
It's over. You can't make RNA, there's no life. You can't make RNA, there is no life. You haven't made peptides, you haven't made RNA. It's over.
It's really just like James lying about science, Dave showing the science, James just dismissing it for some non sequitur of a reason, and that was basically the rest of the debate.
I mean, you
Done.
can say that.
Done. You can't do this, you can't make
You
a
can
cell.
say
You
that,
can't
you
do
can
that, you
cheer,
can't make
but
a cell.
you're
It's
just lying.
over, buddy. It's over.
Although we can just touch briefly on his last 2 points about specified information and assembly of a protocell. So let's hear from James.
Where does the specified information come from, Mr. Farina? Where does it come from? Tell us. Here, take the chalk.
Okay, so specified information is not a real scientific term. It's just was created by creationists. It's pushed by intelligent design proponents. But I think I understand what they're getting at and what they're asking, and I think that it can be answered regardless. So the information that would eventually be incorporated into the genomes of the first living cells, where did that come from, is how I interpret this question. And the answer is fairly straightforward. The Shannon information that exists in the environment is the origin for where the first information comes from for the origin of life, right? The environment around us is full, completely full of background information. There's information about every molecule of the air, its position. All the molecules around me contain Shannon information to some degree or another, information that they just contain around us and is constantly being propagated and changed and new as things interact in the environment.
There's no information there to give you the prescription you need.
What do you mean, no information?
Because what I'm telling you is it has what is called Shannon information. It's information from randomness, which is not
The
specified.
sequence of monomers
you need
is the
specified
information.
So once you have the first self-replicating molecules of whatever variety for your hypothesis of choice, whether those are amyloids or RNA molecules or whatever hypothesis you like, maybe some sort of self-replicating metabolic system of dispersed molecules. There's all kinds of ideas out there. Whatever that self-replicator was, it's taking information from the environment, right? All of these self-replicators work by taking in free energy from their environment. That involves interacting with them and getting some of that information reflected from the environment into that chemical replicator, whether that's the sequence of RNAs or amyloids or the type of chemical substrates available for your metabolism. There's going to be environmental information reflected in that self-replicating system. And from that point on, if you have a population of self-replicators who have a variety of fitness effects, natural selection then acts upon that random environmental Shannon information, and that's what specifies it into useful information for a genome. Some sequences of amyloids are going to be better and more stable than others. Some of them are going to have amino acids that are more available in their environment and thus can replicate their own template faster and thus are going to take over the population. There are already selection effects and already natural selection acting upon this environmental primordial Shannon information that is just inherent in the formation of RNAs or amyloids or any of these sequence-dependent macro oligomers. That is where the specified information comes from. It's from natural selection acting on the information inherent in the environment. I hope that James can understand that answer and maybe watched all the way to this point in the video to hear it. Something tells me, though, he's probably going to say the same thing again next week. So what about James's final point, huh? Bringing it all together and tying it up with a nice, pretty bow. Take it away, James.
The assembly of the above components into an integrated, functional, living system, namely a cell, not merely a random mixture of these. Where did it come from? You couldn't make it. And you can't assemble a cell and you can't bring one back to life.
Switch to something else, right? Switch to something else. Don't look at this research. Don't look at fully self-replicating molecules. I guess if I write clueless a bunch of times, I won the debate, right?
All right, so let's just drive it on home, right? So James says that we are clueless, utterly clueless about the origin of life because of all these criteria, and we've debunked all of them. Now, the final criteria, James wants the complete mechanism for the formation of a protocell. Well, James, sorry to disappoint you, but abiogenesis is a series of competing hypotheses at the moment. It's not a consensus theory like evolution or germ theory. We don't have a mechanism to go from just prebiotic molecules to a protocell fully fleshed out and worked out. That does not mean that we are clueless, though. I hope you're listening to that, James. If you guys couldn't tell yet, my own personal favorite hypothesis for abiogenesis is the amyloid world hypothesis. So let's just go through some of the actual empirical, experimental data that shows that we're not clueless about the origin of life and the formation of protocells from amyloids, shall we? Here is that paper showing amyloids spontaneously forming an aqueous solution with prebiotic reactants like volcanic gases. Here is just one of dozens of papers showing catalytic functions of amyloids, including the ability to hydrolyze ATP and synthesize it. And ATP chemistry is the basis for every metabolism on Earth, and amyloids can catalyze it. Amyloids also have favorable interactions with lipids, which, by the way, James, the construction of these 5 criteria is just on its face of it already dishonest because you left out lipids. Literally one of the most important chemical groups for life that composes our cell membranes, and James left it out, and I know why. It's because we know very, very well how lipid membranes can form prebiotically. So because it doesn't fit his narrative, obviously, that doesn't get included in one of James Tour's 5 points, even though probably like 20% of our dry weight is lipids. They're one of the most important classes of molecules, and James just completely leaves it out because we're not clueless about how they form in the origin of life. That's why. He's just dishonest right out the gate with just how he constructs these 5 points. But amyloids can form in the lipid membrane, like in the little membrane that would become the cell membrane. Amyloids can form in that, and they can interact like membrane proteins do today. And they can have hydrophobic and hydrophilic regions, meaning that they can form inside the membranes and outside, and it increases both the stability of the membrane and the stability of the amyloid. It's literally the perfect fit. Speaking of the perfect fit, amyloids also have favorable interactions with the building blocks of RNA. And the real kicker is that they encourage these RNA building blocks to come together in triplets. That's the most stable form of this interaction between amyloids and these RNA building blocks, like the triplet codons of the genetic code. It's literally all coming together and is explained by amyloid chemistry. I mean, literally so many signs are pointing to this and showing how a protocell can be built from these parts of amyloid proteins, lipids for the membrane, and then like nucleosides can act as these energy currencies like ATP, which is made of adenine, which is the A in the RNA code. I mean, we haven't built a working protocell yet, but we're far from clueless. Each one of these data points is a clue that's pointing towards that abiogenesis chemistry. And that's just one of the hypotheses that scientists are researching. Like, there's entire fields for RNA research, for iron-sulfur clusters, for metabolism first, prebiotic non-enzymatic metabolism. There's so many fields. We're so full of clues about life's origin that for anybody with a straight face to try to say that we are clueless has to be lying. And to close out this video, it's just really important to analyze why James Tour is doing this. Because he knows that there's a naturalistic explanation for the origin of life. Like, he fully acknowledges that this is not a supernatural miracle. He acknowledges that this is a naturalistic process that science will one day discover. So why is he doing this?
All origin of life researchers will die of old age before they solve this problem. And their students will die of old age before they solve this problem. because it's getting further and further away from us, Corey. But I could never say that we will not do it. But even if we do, so what? I presume we will in time figure, okay, this is the mechanism by which God does this. That doesn't lessen God. It makes God greater in my view. So even if we do make life in the lab, that doesn't stop there from being God. I mean, just like, wow, here's how he did it.
I think that from everything that we've all seen tonight, that everyone knows that there's something going on up there. But why don't you let us know in the comments what you think that is, and why James Tour does these kinds of antics and spreads these kinds of lies about science when he knows full well that one day we will have a scientific explanation for abiogenesis. And I just want to say a huge thank you to Planet Peterson for hosting me and this takedown of James Tour on his channel. It was a long time coming, the way that this man lies and misrepresents science for his religious ends. Let's just say he needed to be debunked. If you like debunks like this, check out some of the other ones that I do of young earth creationists and others on my channel, Grayson Hawk. And if you're not already subscribed to Planet Peterson, what is wrong with you at this point? You watched this far into this video and you're not subscribed? What? No, hit the subscribe button, hit the bell, and like the video. What are we even doing here? Come on. Planet Peterson's video is awesome. Thank you for hosting me, Eric. And remember, everyone, keep curious and stay learning new things. I'll catch you next time. I'm heading back to Earth.